Welcome everyone, I'm Effendi. Today we are going to discuss on the relationship between theory and data. To start the discussion, let us go to the definition of theory and data first. Based on my reading, a theory as used in science is an explanation or model based on observation, experimentation and reasoning, especially one that has been tested and confirmed as a general principle helping to explain and predict natural phenomena. Whereas data represents the more or less result of observation and measurement, for instance, the raw products of experimental procedures or field observations, such as the position of a planet at a given time relative to fixed stars. So back to our main topic. Mong Lang, how do you think can we relate between theory and data?
Thank you, Effendi. I'm Mong Ling from the team. And to summarize, I think Effendi says data means raw reading and theory are some sort of like processed information that we can use. Alright, so let me explore further what's the relationship between data and theory. So the relationship between them can be described as a two-way traffic. Let me explain it a bit further and go into a deeper one. A scientist works actually on an experiment, produces the initial data that he obtained from some observations or some experiments. And these data are actually collected into some statistics or some way to be grouped to devise a theory. This theory is used at a later stage to produce predictions of which on further data. So these predictions can either be good or bad. So the good predictions would kind of reinforces the theory, whilst the bad predictions would sort of like created some problems, and amendments are actually put up, and at some point in time a new hypothesis have got to be made on this theory to make it more robust. So let us go into a further example. So what do we mean by data created theory? So an example is this: a falling apple, that's from Newton's time, create the discovery of this law of gravity that says that everything pulls stuff towards the earth. So as we see, data actually plays a very important role in the establishment of a theory, and this data can be regarded as the tinder of a theory. Once theory is devised by some scientist, supporting facts or data needs to prove his theory. But this question arises: what exactly and how exactly can these facts support a theory? I will let my friend Zhang Shu to continue with this discussion. Thank you.
Okay. Hi, I'm Shu. And while theory cannot be proved by enumerating a finite number of facts, and thus providing a theory seems impossible at this stage. However, scientists have proved any sentence uttered from his mouth because it counts for their scientific honesty. Thus, a compromise is made. A theory cannot be plain proven. However, there was this idea known as the inductive logic, which stated that it is possible to claim a particular theory is proven with a high probability based on the available total evidence. As far as I know, that this idea was questioned by Karl Popper, one of the most influential philosophers in 1934. He argued that the mathematical probability of all theories is zero, given any amount of evidence. Now, it seems that scientific theories are not only unprovable, but also unlikely to be true.
I'm Sudiana. I would like to add something to Shu's point. What Popper and his fellow researcher Tom Kuhn failed to discover is the remarkable tenacity of scientific theories. A scientist does not abandon a theory merely because facts contradict it, but they will do whatever it takes to save their theory. For example, by introducing some rescue hypothesis or simply ignoring the anomaly if it cannot be explained. In other words, evidences and data that are consistent with the theory are kept as the essence of the theory, while contradictive ones are pushed to the margin as unsolved problems or special circumstances where a different or an auxiliary hypothesis applies. Actually, this is the central idea of Imre Lakatos' new methodology in his recent programs. All those abnormal data and auxiliary hypotheses at the brink of the theory are called protective bed. Sometimes they can be converted into positive evidence to fortify the hardcore of the theory with sophisticated mathematical techniques.
So, to conclude our discussion, we can say that once a theory system has been established, this particular theory can produce data or predictions. As the example from the prediction of the Halley comet in 1686. Novel facts which are never been seen before are produced, and theories can lead to those unknown discoveries. However, not every prediction from a theory is correct and successful. Some of them may be as stunning as those counterparts, but they fail in the end. Therefore, we are able to judge a theory by the correctness of its predictions. If it matches with what happens in the real world, then the results solidify the original theory. Otherwise, the scientist has to think of a way to mend this inconsistency of his theory, or a new theory is needed. So I think that should wrap it up. Thank you very much for your participation.